I'm going to record some of this. Okay, so this first slide kind of gives you a visual. I will make sure this is on Canvas also, but this kind of just gives you a visual of like the examples of what we just did here. So the first one is what's referred to as a simple random sample. We'll talk about the specifics about a simple random sample here in just a second, but it is just as it sounds. It's the most basic. It's the idea of, whatever population you want to have, you put all of those names. So if we're talking upper school students, we would put everybody's name on a slip of paper. We would put it in a box. We would mix them all up, and we would just randomly choose 10 names or whatever we're doing. So that's the idea of a simple random sample, okay? And that's the visual there just to kind of help you with that idea, okay? Let me highlight some of this. Oops. All right, Ireland. Okay. We will talk more. There's more specifics I will give you about simple random samples shortly. Stratified sampling, remember I was talking about how you're in groups first. So in the case that we did here, we did different colors, right? So if you notice the way it's looking visually is it's broken up into groups, and then randomly within each of those groups people are chosen. So that's the idea of stratified sampling. Cluster sampling, remember what I said about cluster sampling is it's kind of a geographic thing. If you notice, it says first select clusters at random and then use all of the individuals in the clusters as your sample. So for cluster sampling, you're using everyone within that group. Whereas the multi-stage, they're calling it two-stage here, but whereas the multi-stage would be like you do cluster sampling, and then within each of those groups, you randomly choose 5 people from each of those groups, something like that, okay? And then the last one is that systematic, where we are gonna, if you notice they're saying count off your population. So if you notice it's saying, okay, we're gonna start and we're randomly choosing that first number, and then we add, in our case it was 2, thankfully, that made it easy, but in a larger sample. And that's usually when you would use systematic sampling, is if it's a larger group. If you're having to choose a sample from, 600 people, you don't want to have to, that can get kind of overwhelming. So you randomly choose the first number. So you say, I'm going to randomly choose a number from 1 to 50 as an example. And then I'm going to, whatever that number is, I'm going to add 50 to each of those numbers. So what was the example I gave earlier? It was like, we randomly get 37, and so then we're going to add 137, 237, 337, 437. They're going to be part of the group also. So you're systematically adding that same number. Okay, so that's the idea of the systematic. Okay, and then we talked about the voluntary, and we'll get back into that as well.
We have a quiz on this, right?
You do have a quiz on this, yes.
Is it next week or this week?
Good question. Next week, I think. I'm pretty sure it's next week.
So cluster is just like a group.
Cluster, think location, think geographic.
Okay.
Is kind of the best way to do it.
So part 1 would be like, I'll select 10 random people out of Orlando, Jacksonville, and Miami.
Yes.
Okay.
That would be multi-stage. Yep. Yes. Okay. So it's not always reasonable or feasible to be able to survey or look at an entire group and some information. And so that's why we need to use sampling. So that's the whole idea of what we are looking at now. It's a natural thing to do. If you notice, think about sampling something you are cooking. You do a taste test, right? And you taste a little bit of it, and that's the idea of sampling as well. You just guess? You don't taste test your food?
I don't even know how to make sugar.
Um,
I thought sugar was a salt.
Sugar on steak is pretty good.
I thought the sugar
That sounds disturbing.
See?
Opinion polls. So guys, some vocabulary here. Opinion polls are examples of sample surveys. It's designed to ask questions of a small group of people in hope of learning something about the entire population. So remember, the whole idea here is that we're getting this sample to represent the entire population. It needs to be random. We've already talked a little bit about the fact that if it's not random, then there's going to be bias. Yeah, we'll talk more about bias also. If you notice, it says professional pollsters work quite hard to ensure that the sample that they take is representative of the population.
Wait, could you lie on
In
the
other
survey?
words, is random.
You
Could you what?
If you know when it
could.
You can. It is, yeah, that's one of the things we're gonna talk about, is the fact that some people do lie. Some people lie on purpose, and some people lie just because they don't really know. So let me give you an example. If you're being asked questions about like illegal activity, the likelihood that you're gonna be truthful is not very good, right?
Preach on that, that's so true.
Okay, but let me give you another situation. If I were to ask you, how many movies have you seen since the start of the new year? In 2024, how many movies have you seen?
No idea.
Are you gonna be able to tell me exactly?
Not really, no.
I could probably
Okay,
count it out.
so that is what's referred to as response error when you are lying, right? But response error might also not necessarily be that you're lying, but that you're gonna give me an estimate, a guesstimate, I should say, because you don't really know. Like, you could say, it's probably close to 24, but do you really know?
You gotta be like oddly specific. I feel like to like be accurate on these polls, you need to be like really specific to what you're
Yeah,
talking about.
exactly.
I've seen 4 since the start of the year.
Okay,
I've seen Killers of the Flower Moon, Fight Club, Inception, and I saw an anime movie.
okay,
That's,
there you go.
That's it.
All right, Apple Pencil is low too. I'm just like,
You're out of battery today.
yeah, I guess, which is weird because I had this plugged in overnight. All right, bias. We talk about bias in kind of a general sense. You need to be aware of that because that is part of what we are talking about. Statistically, though, when we are talking about bias, what we mean is that it's a consistent overestimate or an underestimate of what the true results are. So bias tends to lean in one direction, in other words, right? So in other words, if I were to do a sample, if I wanted to do a survey here at school about parking on campus, but the majority of the people I interviewed were 9th and 10th graders, do you think there's gonna be some bias there?
Yeah.
Probably.
Yeah, it's that most of the people who really need to be represented are not being represented, right? So that would be biased.
We should do a poll on the people who park in the senior lot.
The best way to avoid bias is to select individuals for the sample at random. So guys, we're gonna talk about all of these different ways that you can make sure that you are choosing random, okay?
Anonymous. If
Randomly,
you were picked anonymously, doesn't that also greatly increase the chances of like accuracy
yeah.
if you're anonymous?
Well,
Yes.
well, not if you don't wanna like do it like.
Okay, the idea of randomization, if you notice, it says it can protect you against factors that you know are in the data. It can also protect against factors of which you are not aware. So there's gonna be some things that are gonna kind of affect results a lot of times. Sometimes you know about what those things might possibly be, other times you don't. That's what this is getting at here, okay? Unless we are randomizing, we can't really make inferences about the entire population. So if we're doing random sampling, we're better able to actually use that information and say, here's what we know then about the population, right? If we get results here, if we survey a random group of high school students here and we find out that, I don't know, 55% of the high school students that I surveyed prefer Coke over Pepsi, whatever,
Pepsi's
right?
better.
Then we could, as long as I've done that randomly, then I can make the inference then that 55% of teens prefer Coke over Pepsi, or whatever it was that I don't even remember what I said anymore.
There's more metallic.
Pepsi is better.
Okay. The size of the sample that we choose is going to be important. and we'll talk more about that on the road as well.
Diet Pepsi is like the best.
Okay.
You might be the first person I've ever heard say anything about Diet Pepsi.
Listen, I've been drinking it since I was a little.
He was so proud of himself.
All right.
You guys don't like Diet Pepsi?
So you guys need to be familiar with the term census. And
Oh.
census we will use in two different contexts. If we're talking about the United States Census, then that is what's done every 10 years where they are trying to learn and find out information about the entire United States population. What's the issue with trying to do a census in the United States?
There's a lot of people.
There are a lot of people, and as you notice, what it says here, populations rarely stand still, right? People move, so it's hard to actually keep track of all of these people, okay? So we can talk about the US Census, that is that idea of using the government to try to find out all we can about all of the people here in the United States. We can talk about taking a census, though, if we are doing a survey. Could I take a census of this particular class? Yeah, that would be really easy because there's only 6 of you to ask the question of, right? Would it be reasonable for me to take a census of the entire upper school, of all upper school students?
Yes.
It would be hard.
You can send an email.
That would be very hard. What's the problem with sending an email?
The admins are gonna get
Then
on you,
some
bro.
some people might respond, some people might not respond. So you
Last
can't
time-
just send an email,
Last time
right?
They send emails
So
to
for
people.
me to be able to make contact with every upper school student, probably not likely. But that's the idea of a census. So please realize sometimes your population of interest is a smaller group. So it may or may not be reasonable to take a census.
Last time, someone sent an email to the school, they got like suspended.
Okay,
You guys remember that?
some other vocabulary.
He CC'd the whole school.
All right,
Yeah, he CC'd everyone. And then
some
he got
other,
suspended.
some other vocabulary here that you need to be familiar with.
Nah.
So a parameter explains about a population. Think alliteration here. P goes with P. A parameter explains a population. And then a sample has to do with statistics. So S and S go together, P and P go together. So parameter is a term you need to be familiar with. It has to do with a statistic about a population. And then there's the sample statistic, okay? So statistic explains something about a sample, just like parameter explains something about a population. All right, you guys are already familiar with the variables, the letters that we've used in order to kind of represent mean and standard deviation, so I'm not gonna spend any time on that. Let's talk about these different types of sampling again. So simple random sample. Okay, simple random sample, it is abbreviated SRS. Guys, you need to know this. I can promise you this is gonna be on the quiz,
You're
okay?
gonna take out another quiz?
Two things
Is there a
two
test?
things that make a simple random sample a simple random sample, okay? It is truly the idea of just taking everybody's name, putting it in a box or a hat and mixing them all up and adding, and pulling from that. That's one way that you can do a simple random sample. And like I said, I'm gonna explain a couple other ways that we randomize here, okay? Hold on. Two things you need to know about a simple random sample.
Quiz, probably next week.
Every individual has an equal chance of being selected. So each person in the class would have the same chance of getting chosen. But then also every sample, every potential sample has the same chance of getting chosen also. So let me explain what that means, right? We have 6 students in this class. If my sample size is 2, then I need you to think about the fact that all of the different possible samples, it could be Jack and Vishal, it could be Jack and Ahmed, it could be Jack and Aiden. It could be Faith and Aiden, Faith and Ahmed, Faith and Vishal, Faith and Jack. It could be Jonah and Ahmed, Jonah and Vishal, Jonah and Jack, right? So those are all possible samples. So every single one of those has the same likelihood of getting chosen also. So that's the idea of an SRS, okay? Ahmed, does your question have to do with this?
Yeah.
Okay, go ahead.
Like one time I was watching YouTube and like every time I watch a YouTube video, they always like prompt me with like a poll. What would it call that? 'Cause,
Oh, like in the ad?
yeah. It's like what kind of like
That's called voluntary response, because you choose whether or not you want to respond to that. So that's voluntary response. And what did we decide about that? Is that going to be a good way to get information or no? No, there's going to be a lot of
Someone's
bias.
probably like fed up clicks or random answers.
No.
All right, onward, because that's still about various sampling designs. Okay,
That's what I'd be doing on
so
YouTube. I'll answer just like
stratified-
completely wrong.
stratified sampling. Guys, notice we have groups. The most important benefit is that stratifying can reduce variability of our results. It sounds a little bit weird to say we're going to break things up into groups first and then we will take samples, but that does a lot of times give us better information. This is going to be if you're doing like an experiment. A lot of times you want to compare male and female, or grades 1, 2, 3, or grades freshman, sophomore, junior, senior. So those are examples of stratifying, right? It's groups. So there's kind of a visual to help you with that. Yes, these notes are going to be online for you. And then let's talk cluster and multi-stage again. So on this one, if you notice, it's literally kind of showing you like on a map, and it's saying visually, okay, here's zone 1, zone 2, zone 3, zone 4. So cluster sampling would mean you randomly choose 1, 2, 3, or 4, right?
Bet.
Multi-stage would mean you would choose one of those and then you randomly choose people within that particular zone in this particular case, the way it's wording it. Cluster sampling is not the same as stratified sampling. We stratify to ensure that our sample represents different groups. So the groups are important with stratified sampling. Clusters are more or less alike, right? People who live in Windermere are very similar, right? People who live in Ocoee tend to be similar, that type of thing. So there's a resemblance within the overall population if you're looking at that type of thing. All right. So sampling schemes that combine several methods, that's when it's called multi-stage, okay? All right, this is systematic. So the example they're giving here, you might survey every 10th person on an alphabetical list of students. And that's kind of another example visually of randomly pick that first number and then you're repeatedly add something. The population of interest, it's important to know who you're wanting information about. That's kind of going to give you what's referred to as your sampling frame, and then go from there, right? So then from there you have to think about how you're going to get your sample. How to sample badly. So we've already talked about voluntary response. There's another type of sampling that's not so good, and that's what's referred to as convenience sampling. Let me give you an example of what that would be like. Convenience sampling would be if I decide I want to ask questions of people of students in the upper school, right? If I sit outside the cafeteria, if I sit outside one of the cafeteria doors and I survey people and ask questions of people who come in and out of the cafeteria doors, that's convenient for me, but is that going to give me a good random sample? No, why not?
They're all hungry and don't want to answer your questions.
Okay, that might be part of it. First of all, they might not even want to answer the questions, and that's their choice. And that's called non-response, because they're not even responding. But not everyone goes there, right? That means I'm really kind of limiting and I'm causing bias because I'm only asking questions of those who are going into the cafeteria, who eat in the cafeteria or go in there. And some people don't at all. And I need a good representation of the entire population. That's going to limit me, right? Okay, under coverage, this is kind of part of the problem, right? The idea of under coverage would be that if I were to do that sample where I'm sitting outside of the cafeteria, then I'm not representing people who choose not to eat at the cafeteria. So there would be undercoverage. That part of the population's not getting represented, right? Non-response, that's just if they choose, like you were saying, Vishal, if they just like, they're hungry and yeah, no, forget it, I'm not even gonna talk to you, right? So that's the idea of non-response. But then when you do respond, remember we talked about the fact that people might lie, or they might tell you an answer that they think is accurate but might not be real accurate. So response error is a real thing too. So we'll talk about that as
Like,
well.
when they ask you, like, are you a convicted felon?
I'm sure they would. That's like when they made us do that Black Watch survey, and everyone was absolutely over it because it was way too long. And it asked the same questions like 3 times.
Our survey is fire.
Are you a convicted felon?
Well,
Wait, it was like 100 questions. The personality one?
Okay.
I like that one.
All right. So grab a pencil. You do not want to do this in pen.
Someone stole my pencil, bro.
So go grab one from in there. You're gonna want pencil and not pen for this. Okay, so if you notice on the back of this, there is a random digits table, and I'm going to help you understand how you use this. Okay, where did I put my? Okay, and then we're also gonna talk about how you do this using your graphing calculator. So you need your graphing calculator also. Okay?
You're gonna get me that in 10 minutes?
Yeah.
Crazy.
Okay. So, shoot, I don't have these in the slides in the right order. That's okay. All right, if you flip to I would suggest you write this information on the next page. I'm gonna write it up here just because if I switch back and forth, it does goofy things when I'm recording. Okay, but you're gonna wanna make a list of a couple of requirements. If we are using the table of random digits, there are a few things that you have to be aware of, right? Each subject or each person or thing all must have the same amount of digits, same number of digits. And I'll explain that in just a second. We obviously can't have any repeats, right? If we're choosing randomly, we can't choose Ahmed twice. So if we were to choose, put it underneath that table. So no repeats. And then we also want to make sure that we are using the smallest number of digits possible. So in other words, if there are only 10 subjects in a sample, then we're going to number them from 0 to 9 because that covers 10 people. But that's using 1 digit, okay? If there were 11 people in a set and we had to randomly choose, then the way we would number them would be from 0, 1 up to 1, 1, right? It would be 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. You have to use 2 digits, even for those first people, because you have to have the same amount of digits for each person in the group, okay? So we'll look at that in just a second. If there are 10 people, we could number from 0 to 9, and that's still gonna cover 10 people. If there are 100 people,
0 to 99.
then we're gonna number from 00 to 99, and that's gonna cover all 100 people, okay? So for this first example here, it says, you need to interview 5 managers in a company about the management assessment system. We've got to randomly choose, and we're going to use this table. Okay, so here's how this works. We have to number these people first, and there are 28 people, so that means they have to be numbered 01, 03,
Wait, 0. Oh.
all the way up to 28, right? So we got to number all of these.
Castro. Chavez, what is this name? Dictators?
Gupta.
What's the name?
22. I just pulled this question out of a textbook as a resource, so. Okay, so if we wanna look at, if in this particular case, it says you need to interview 5 managers in a company about the management assessment system. We have these numbers here from 01 up to 28, right? If you're doing this on a quiz or a test, then we all need to be on the same line. If I truly needed random data from every one of you, then I would say, you go to this line, you go to this line, you go to this line, you go to this line. So we're getting different answers. But we need to practice, and I need to make sure you understand this process all together here, right? Okay. So, yeah, I'm gonna have to jump here. This is not gonna be good, but oh well.
Can you just like circle?
All right, man.
So then you're gonna wanna make that list here of,
So we started at line 152 now.
what was it,
We're at-
17,
but you
oops.
go to, right, so it's 45, another two,
17, what did we get? 17 and 9 and 22 and 13 and 07.
in our list, right?
So whoever those people are, so
Right, then you carry over again, too big. 55's too big, 80's too big, 0, 0, we don't have.
Fernandez,
Like that, might have 0, 0.
Puri,
Oh, so just the numbers are under.
Gupta,
And you go by twos, right?
and
How do
Chavez.
you know what numbers are under by?
I'll read your list, so 28, so that's.
Okay. All right. Grab your graphing calculators, and let me talk you through the process for this next one. We probably will have to stop there. We won't get to 3 and 4, but we'll talk about those a little bit more. On your graphing calculator is another way that you can get random digits. Notice it's saying a population of 150, we want to randomly choose 4. So think about this for a minute. If you were going to use the table of random digits, you would have to number from 001 up to 150. Now, on your calculator, you can just say you're going from 1 up to 150. It does the random generation.
This table doesn't seem random though, because if I had 4.
It is what's referred to as semi-random, but it works for what we're
How do you
doing.
achieve true random?
Yeah.
Calculator, but we'll have to get into that, and
It seems like even the
By-
calculator wouldn't be able to do it 100%.
it will. I mean, part of it is that it's a program, so it is kind of what's referred to as semi-random, but we're gonna talk about how we're gonna seed our calculators. All right, so here's how you plug in. If you go to a calculator page, so you wanna go to menu, and your calculator page and then menu, right? And then you're gonna go to 5, which is probability, and 4, which is random, and then 2, which is integers. Now, in this case, we wanna go from, it says rand int there, right? We wanna go from 1 to 150, and we wanna choose 4. So if you put in there now 1, 150, 4, and hit enter, what did you get?
142, 143, or 137, 123, and 78.
123 and 78?
Yeah.
Did you all get the same thing?
No.
Oh, not 123, just 23.
Oh yeah, just 23.
Oh, just 23.
But I got the same as that.
Aiden, I needed you to do this, because I needed you to see how this works. Here's the issue. The way your calculator is set right now, it's the default setting, so it's what's referred to as the seed, right? So we're all getting the exact same random numbers, which is great for a quiz or a test so that I can know you understand how to do that process. But if we truly need random numbers, we gotta reseed our calculators. So I've gotta remember, I need you to remind me, next time we are in class together, I gotta talk to you about how we're gonna reseed our calculators. Okay, so reseed our calculators.
So wait, I did menu 541, now I do.
Menu
542. 542.
Is this due, like, we'll do this, like,
Okay, so we are gonna go to line 103.
Wait, why 103?
I'm just telling you a line to start with,
Okay.
okay? So we're gonna go to line 103. And we need to look, we're looking for two-digit numbers, and part of it is this is not the easiest to see. I get it, it's not easy to read this.
Oh, like 45,
But we have to look
46.
at this as two-digit numbers, so the first two-digit number is 45, exactly. That's too big, isn't it? That's we don't have a 45. We also don't have a 46, that's too big. 77 is the next number, that's way too big. So the first random number that we're getting is 17, and then this 09. 77's too big, 55 is too big,
And 1.
80 is too big, 00, we didn't number that way. 95, 32 is too big, 86 is too big, we got another repeat of 32, 94, 85. We got to keep going. Notice we're going down to the next
What are
line.
we doing?
22
Or 22.
Wait, what are you doing?
and 26.
Okay, slow down. So we did not get all of the numbers that we need. What did we get? We got 17 and 9 so far.
Yeah.
No, wait, we
So
have
we're
more.
looking for numbers that are under what?
We have more if you keep going.
Yeah, we have to keep
Oh, yeah.
going. We have to keep going. But what I'm saying is, if we get to the end of this row and we still don't have what we need, we gotta go down to the next row. So-
We started on 103, but we're crossing the numbers that are higher than what number?
Then higher than 28, because we only have up to 28. Okay, so 82 is too big. 22 is the next number.
0,
69 is too big. We don't have a 00. We don't have a 56. So we're going down to the next row, it looks like.
Yeah.
13 is the next one we can use.
52's too big. 71's too big. Yeah, it looks like the next number that we would have is 13. So we have 17, 9, 22, 13. We need one more.
7.
And where do we find it? 7. You're right, it is. It's 07 is what we end up with right here. The others are too big. Ahmed, you okay with what we were doing there? And Jack?
We're supposed to choose 4. Oh,
5.